Okay, please make sure that you have your 6.1 factoring out the GCF of the polynomial notes. You can find those from over by the windows, or if you are with Miss Alfie and or Mr. Rivera, you can ask one of them for a copy of these 6.1 notes. You will also need a regular pen or pencil, preferably a pencil, a red pen or pencil, again, preferably a pencil, and a green pen or pencil. If you'd like, you can also have one additional color. I'm going to use blue at some points here. So let's start with some of our notes here. So first, we're going to go through some vocabulary. So we have to factor. So this is the verb factor, to factor. This is the process of pulling apart multiplication. We then also have the noun factor, so noun being a person, place, or thing, and that is a term that can be factored to get something else. So you actually have know what factors the noun are, and you have done factoring in the past. You've just done them with numbers instead of variables and expressions like we're going to start today. This term GCF should be familiar. This is the greatest common factor. The greatest common factor, and it is the largest factor that every term has in common. So we have to look at every term in an expression and make sure they all have that in common for our greatest common factor. And then a coefficient is a number being multiplied before a variable. And a constant is a term with no variable. It is just a number, so it doesn't change because it has no variable. It's just a number. So let's start by thinking about what are some different ways to factor just a number. So we're going to factor the number 20. So what are some different ways that we can multiply to get to 20? Well, maybe you're thinking, oh, well, 4 times 5 gives me 20. So 4 and 5 are factors of 20. You could also do 2 times 10. That would give me 20. So 2 and 10 are factors of 20. You could also do 1 times 20. That would give me 20. So 1 and 20 are factors of 20. That is what we are thinking when we are thinking of factoring. All right, let's open up these notes and we're going to take a look at the steps we're going to use and then also some examples here. So I just want to point out that the steps we're using here is one method for factoring out the greatest common factor from an expression. If you find a different way that works better for you, you can absolutely use that. What I like about this method is that it's accessible for everybody, no matter where your number sense lies and no matter what you're noticing about different expressions. So I'm going to switch over to my blue. I like colors. So I'm going to switch over to my blue and I'm going to have that red close by. So our first step here, we're going to use division. So we're going to start by writing the polynomial under an upside down division sign. So let's put that upside down division sign there. So it's going to be, if you think of a division sign, if we're doing long division, we're just going to make it upside down. Then we're going to divide by a number that divides evenly into each coefficient and constant. So when we're thinking about that, it has to divide into every coefficient and constant in the expression. And then we're going to check and repeat that step until each term can only be divided by 1. Then we're going to look again and see if all of the terms have a variable. And if they do, then we are going to divide by that variable that each term has in common, and be careful with the exponents if we can divide out an exponent as well, which we'll talk about in a little bit. The GCF then, if I'm switching over to red, is everything you divided by multiplied back together. So anything you divided by in steps 2 and 4, you're going to multiply together for your GCF. And we'll write our final answer as the GCF on the outside times what's left on the inside of the parentheses. Let's look at this first example here. So I'm going to rewrite it just so I have a little bit more space. So we have 18y cubed minus 15y squared plus 3y minus 6. 18y cubed minus 15y squared plus 3y minus 6. So putting in my upside down division sign and then thinking, what number can I divide 18, negative 15, 3, and negative 6 by? Well, I can divide all of those by 3. So if I do that division, 18y cubed divided by 3 would give me 6y cubed. Negative 15y squared divided by 3 would give me negative 5y squared. Notice those variables and exponents staying the same. 3y divided by 3 leaves me with just a y. That invisible 1 in front, you can write it there if you need it. And negative 6 divided by 3, negative 2. Repeat step 2 until the only number that divides into each term is 1. So if I look, I have 6, negative 5, 1, and negative 2. There's no other number other than 1 that I can divide those by. Step 4, divide by any variable that each term has in common, but notice this one does not have a variable, so I can't do that. So I've only factored out a 3 here, so I can skip down to step number 6 to write out my final answer. 3 is my GCF. In fact, let's label that. That 3 is the GCF. So 3 times what was left, 6y cubed minus 5y squared plus y minus 2. All right. Let's look at example number 2. So again, I'm going to rewrite this. We have 25x to the 5th plus 5x to the 3rd minus 8x squared. Excuse me. Dividing this, looking at first our numbers. I have 25, 5, and 8, negative 8. I can't divide those by any numbers, but do notice that each of these terms has an x. When we're looking at this, we want to look for the smallest exponent, which here is x squared. X squared has our smallest exponent. You can take that smallest exponent out of each of these. So this has 3 x's. X to the 3rd is 3 x's being multiplied together. So there are 2 of them available to take out. This has 5 x's being multiplied together. So there are 2 of them available to take out. So we're going to factor out that x squared. My coefficients will stay the same because I'm not dividing a number. So if I had 5 x's being multiplied together, but I'm dividing 2 of them out, I will be left with 3. So x to the 3rd plus 5 x cubed divided by x squared, taking 2 of these 3 x's out, leaves me with just 1 x, minus 8, and x squared divided by x squared is just 1. Nothing else I can divide out here, so we can write out our final answer as my GCF, x squared, times 25x to the 3rd plus 5x minus 8. And again, this time, the GCF is variables instead of numbers. Let's take a look at one more example. So we have 32x to the 4th minus 16x to the 3rd plus 8x squared. And you'll notice here this time, we will be able to do both numbers and variables. So I'm going to break this up. You may have seen some different numbers to be able to divide by, but I'm going to break this up in a way to show how that the repeat step would work. So maybe we're looking at this, 32, negative 16, and 8, and you say, ooh, I can divide all of those by 4. You might notice something different and you can divide by that. But I'm going to start here with 4. So 32x to the 4th divided by 4 would leave me with 8x to the 4th. Negative 16x to the 3rd divided by 4 would leave me with negative 4x to the 3rd. Ooh. And 8x squared divided by 4 would leave me with 2x squared. And then I'm going to look because it tells me to repeat that step until the only number that divides into each term is 1. So now I have 8, negative 4, and 2. And I'd say, oh, wait, I can divide that by another 2. So let's do that division. 8 divided by 2 is 4. 4 divided by 2 is 2. And 2 divided by 2 is 1. So we just leave us with x squared. Also notice we have a variable in each of these. And in fact, over here, we have this x squared as our smallest exponent. So I can divide out that x squared. Remember, when I'm dividing variables, I subtract those exponents because I'm taking these 4 x's being multiplied from that exponent, and I'm dividing 2 of them out. So I would have 4x squared minus 2, well, x to the 3rd, dividing out 2 x's would leave me with an x. And x squared divided by x squared, anything divided by itself, is always 1. No more variables to divide. No more numbers to divide. So now for my GCF, this whole thing over here is the GCF. So I need to multiply these all back together. So 4 times 2 times x squared will leave me with 8x squared. And then what's left at the very bottom here? 4x squared minus 2x plus 1. And there we have that. Now you may say, well, couldn't I have just divided by 8 right from the very beginning? Absolutely, you could have, but some people won't necessarily see 8 right away. Could I have just done 8x squared right from the very beginning? Absolutely, if that's how you see it. That's what I love so much about this method, is that it's very accessible no matter what you see. You can still be successful and get to the same answer as everybody else.